Good morning to our honorable judges, ladies and gentlemen. Today, we'll be showcasing our prototype in detail, but before that, let me introduce my team. Ni hao, I'm Shane, this is Ho Bing Chuan, and this is Ho Bing Chuan. Together, we form a dynamic trio.
Without further ado, let us talk about our problem statement. People in Kampung Kesopan, Pulau Gaya have been facing water and food shortage due to the polluted water around the area. The issues of Kampung Kesopan were supposed to be resolved by the government, but due to political issues in 2018, the plan to resolve the problem was abandoned. Our prototype offers to fix all problems faced by Kampung Kesopan, excluding personal issues of course, developed with a low budget, automated and can function without external electricity.
Before we move on, let us talk about our automated aquarium. There are three systems for the automated aquarium, mainly the alum, the fish food, and the slick line.
And now we are going to explain how RFWM works. First of all, water tank 1 will collect rainwater and transfer it into an automated aquarium.
For the first box, you can select any one of the three options that is provided to release alum into the aquarium. For example, you can select option 1 to drop alum for 1 to 5 fishes a day and so on. The function of alum is to coagulate dirt, soot and solid waste products from fish to prevent water clog in the pipes. Okay, so for the second box, it contains fish food and has 3 options to choose from. Option 1 offers an 8-hour interval per feed. Option 2 offers a 16-hour interval, and option 3 a 24-hour interval. As for the third box, it contains slaked lime to neutralize the acidity of rainwater if necessary. When the pH value of the rainwater is lower than 6.7, the pH sensor will send signals to the servo motor and drop slaked lime into the aquarium. We purposely took the pH sensor and dipped it into a slightly acidic solution to prove that the pH sensor works. We also dipped it into normal water to show that the slaked lime will not drop when the pH value is higher than 6.7. After that, we have a light intensity sensor located at the bottom of the aquarium. This light intensity sensor will notify the user's handphone when excessive coagulated waste products gather at the bottom of the aquarium. We use Bluetooth GCM to connect the Bluetooth model with the light intensity sensor via Bluetooth. When the water is clean, the light intensity value is low, so no notifications will be sent to the user's handphone. However, when the water is dirty, the light intensity value is high, so this will notify the user's handphone that the aquarium needs cleaning. Coming back to the main system, the water that overflows a certain level of the aquarium will flow to water the vegetables. This is based on the concept of hydroponic, where the ammonia produced by fish will be used by the plants as nutrients, where the roots of the plants will filter non-solid waste products of the fish. And then, this water will be filtered again and transferred into the second water tank. Finally, when the water in the second water tank touches a capacity sensor located at the top of the water tank, it will open the tap and water will flow through the hydroelectric generator and produce electricity to power the automated aquarium, a battery with an LED to prove that electricity can be generated. After a while, the tap will close back by itself when the capacity sensor is not in contact with water.
Here are some of our codings for our prototype. The first one is our coding for the capacitive sensor. When in contact with water, the value is higher than 130, whereas the value is lower than 120 when not in contact with water. The second one is our coding for the light intensity sensor and the Bluetooth module. The sensor will only notify your handphone when the value is higher than 430. The third one is our coding for the fish food. The fourth one is our coding for the alum.
Last but not least, we want to give our utmost appreciation to Ms. Zyrustina, Mr. Asun, Ms. Penny, Ms. Leong, our fellow teachers, and our friends for the tremendous support and great advice in making this project a success.
During this journey, my team and I have learned that teamwork and time management will always be essential in the success of any projects. We hope that our prototype RFWM will be of use not only to the people of Kampung Kesopan, but also to many other people elsewhere who face water and food problems.
Even if our prototype only makes a small impact to the well-being of the world, we will still do so with great enthusiasm. As the saying goes, great things are not done by impulse, but by a series of small things gathered together. Thank you for listening.